Okay, thank you very much. I'm working at IVL, Swedish Environmental Research Institute here in Stockholm. And I should directly say I'm really not a process control expert, but I like the idea to use it for our aims to recycle chemicals and water in processes. Without the knowledge from these process control technologies, we are limited in what we could do. So I'm more a specialist in separation technologies and closed loop processes, but I use our department quite a lot for process control. So I will talk about how to recover not just water, but also process chemicals, how to improve the product quality in the same time, and show how it could be used in circular economy in practice. So this is a little bit the situation most often, I should say. We have introduced more and more closed loop processes, but most often it's still the way that you mix process water from different part processes, and then try to recover the water or send it to the wastewater treatment plant. And then you have a quite complex water to work with. So if you want to recycle this water, it's complex for more advanced separation technologies. So if you turn it to work with each process and within the process, you will have a much more simple water to work with for recycling, for example, water. But in the meantime, you actually have just split the process chemicals and the water into separate parts. So that means that you have an opportunity to start to also recover process chemicals if you do it like this. I'm going to tell you about how this could be implemented in the phosphating process, today's pre-treatment process. And I think you're quite aware of how it works. But here is just, you have many different process paths with rinse waters between the process path. And what you should be aware of that is that you have a lot of poor correlations between those process paths. What you do in the greasing step will also affect the passivation process, for example. And this is extremely hard to have a good control over all those co-correlations. So I should say that there is a lack of knowledge about the processes, and that is a hinder when you want to start to implement the circular economy into your processes, the recovery of chemicals. Most processes, I should say, still are run rather on experience. You know, if you replace the bath when this level is reached, or after 2 weeks or 1 month, you know that the process is up and running quite well. But this is a hinder if you want to reuse water to recover the process chemicals, if you want to increase the lifespan of process paths or improve or maintain the product quality. If you want to say something, if you have questions, just please ask me. You might also have opposite thoughts about this. So please. But so this is what you used to say is closed loop today. You recycle rinse waters. Sometimes you also separate impurities from the process path and directly into the process path. But if you should do like this, that you return the process chemicals, unfortunately, you will also return impurities. It could be oil, it could be salts, different salts, or chemicals that have been broken down. And when you tell this for the environmental department, they used to be happy. This looks very good. Recover the chemicals. But if you talk to the quality assurance department, the quality department, they might be concerned, as they know that you will change the process. And here it comes. You don't have the knowledge really about the process, and then you're a little bit afraid to change the process. So resource efficient quality optimization could be done in 6 steps. And I will show you later on, but I think mainly in 6 steps. And first of all, you have to get the knowledge about the processes. As we are working with co-correlations between the different process paths, you have to understand how different parameters in each process path actually have an impact on the product quality. Here we are working with phosphating and phosphate bath, and you used to measure it, for example, with the weight of the phosphate layer or the crystal size. That's quite what you used to do. So, and here with multivariate analysis, you used to call it AI applications when you use it for controlling the process as well. You could see how big impact different parameters have on those different parameters in different process paths. You could also, by using multivariate analysis, you could also see how the process changes over time. And this is one example over 1 year in a phosphating process, where in the beginning of the year, the process was running on the right side, but it has been turning to the left side, how the total process changes over time. And this is quite complex. You will not see it in each simple sample or analysis of each process path. This is how it turns around. Yes?
Can I ask you?
Yeah, maybe, if I could answer.
What is the quality in the process parameters versus quality? Or how do you measure quality?
You have several ways of analyze the quality. Here, for example, I think they have been analyzing the thickness, the weight of the crystal, the phosphate layer, but also measuring the crystal size. We have been working in Scania, where we also go not just analyzing the phosphate layer, but also analyzing the paint, how it affected the final result of the paint. And you could see actually from the degreasing bath, or actually even before the degreasing bath, how important the oil, how old the steel plate are when they came into the site. That has quite a big impact on the final result. So you could measure it in many ways. The second step is to learn to predict the product quality by data modeling. Now you have learned what's affecting, but then you could start to take all the samples, all the analysis, and actually predict for example here, the crystal size. This is normally made by sending the plate you have been running through the process, and then analyze the weight of the surface of the phosphate layer or the crystal size. That I think takes a week at least. Here you have the results online directly after you have analyzed the samples. And as you could see, for crystal size, we could have a real good prediction. between observed and predicted, and this is in real time then. But you could also see, I don't have, it's quite a big difference from this point to that crystal size. It was, I think, maybe 100% difference in the crystal size. Here's for the surface weight. I think we don't have the same nice correlation, and that's very interesting because those outliers probably represents results from what you are today measuring. You're not taking samples, you don't analyze those parameters. So this could be very interesting input to try to find what's affecting the surface weight more than that we today analyze, to get rid of those outliers. And when you have set up this, then you could actually measure online and have a good control on the weight in real time applications. And you also could see, as I showed you, the process is changing over the year, going like this. If you have good process control, you could see how it changed and you could control it back. So you have the process not running and changing over the year. So you could, by having this control, you could also ensure that you have a process that is more stable.
One question for the previous slide.
Yeah.
So this is predicted values from the parameters that
Yes.
the crystal size and
yes.
measured.
This is not measured on the weight of it's just extracted from all the yes, the on-site or off-site data. Maybe you take samples every third hour or something like that. And then if you want to be able to start to recover process chemicals, you should also have a better control over the flow in the process line. Very often you think you have a good control, but sometimes it turns out that this whale was actually closed a few weeks ago for some reason, and the water is not running that way any longer. But here you could see what kind of separation you need and the size of separation technology you should need to be able to start to recover the process chemicals back to the process path. The quality department wants you to have control. Now you have good knowledge about your process, but now this is more my part of it. Now when you know what should be separated, you could actually start to selectively separate the process the impurities from the process path. And you also have knowledge to which this is for example, maybe this is acceptable level of impurities. Normally you run it to that point, or you just spend the bath after 2 weeks or 2 months. By implementing a selective separation technology, you could run it intermittent, and you will go up and down, but still below the limit for the process, so it will not affect the product quality negatively. Or you could run it, you could have a dimension on the separation technology, so you could have a stable spring out impurities continuously to a stable concentration, that you could be ensured that it will not have a negative effect on your process. And then you have the knowledge, you have your process control, then you could start to recover the chemicals. but you still have very good process control. So you could see if you have negatively results by recovering the process chemicals back to the bath, process bath, because you will see it directly if you have some problems. So therefore you could start to recover more chemicals, all the chemicals back to the process bath, and then separate the impurities selectively. So, and of course, maybe you will not be able to separate all impurities by selective separation. So probably you still will need to replace the process bath sometimes, but much more seldom. So by using this technology, you could recover water and process chemicals, and you could then, by that, increase the lifespan of the process bath. Instead of sending the process chemicals to the wastewater treatment plant, you could recover them, replace waste with recovery and a circular economy approach. And if you have better knowledge about the process and how it affects the product quality, you might also be able in the future to have improved product quality. So yeah, that was roughly what I tried to tell you.
Any questions?
I have a question. Do you know anything about the process that you will need to implement to remove those impurities?
Yes, it could be different impurities, but if you should start to work more detailed and do some research, most often you could find a combination of separation technologies that could actually fit the purpose. Some impurities are much harder to get rid of, but most often you could bring them out with a separation technology, or maybe a combination of them.
Because this practical work you did, that was together with Scania?
This is several different, yeah, but Scania has been one in Oskarshamn.
Those companies, are they looking into those separation technologies, investigating them to implement?
Yes, I'm not really aware, for example, in Scania and Oskarshamn, maybe someone or here, yeah, because when we started up this, then you have this, you have quite recently started up this closed loop process line.
Yeah, I don't know the details, but yes, we have an up and running some ways of.
Yeah, and then you face some problems, and that was the reason we came there and tried to find better, improved ways for separation.
Of course, I don't right now.
Yeah, yeah, I think you don't have. Yeah, to be able to meet the limits, you need to recycle the. But then it was obvious that you also actually you send the concentrates from those separation technologies to the wastewater treatment plant quite often. And then we thought, why don't, in discussion with you, why don't see if you could actually recover the process chemicals instead of send them as a waste. And then we started up to work with the quality department as well, and that was very interesting. And then we get deeper and deeper. Yes.
If you have this treatment line, you have activation, zinc passivation. Which one of those would give best payback if you would start today?
I can't remember. I think it could, yeah. I think you could also maybe see how much waste will they produce, etc., and what is the cost for each process path, and how. But due to the quality, I could check that. I can't remember those that. But I could check in. I think we have it in our report. Yes.
The volume of classification.
Yes.
Which one would give the best takeaways?
I don't have it in my mind, but that's really what you would like to use the results to see and estimate what is most important. Do we have 100% difference in the crystal, or is it important? Maybe it's 100% doesn't affect the paint layer, but if it does, maybe you should focus on how to squeeze this. Or is it the cost, maybe, or secondly, you could go for the cost, maybe, or like that. And then to take also the waste into the calculation, of course.
Yes, in my experience, when it comes to process bath, to recycle them and have them live longer, our experience is that some sort of process bath needs to be changed more often than before, because it makes a harder job for the water treatment plant to take care of it. So we see it takes a lot more effort in the water recycling plant to take care of the process bath if we have it too long and recycle it. Our job at that end. But it's not the benefit when it comes to the end of life, when we have prolonged the life.
Then you have problems with your wastewater treatment plant.
Yes.
And do you know why this is happening then? Why is it harder to?
It comes down to what chemicals. It's a more complex issue.
Yeah.
But we have tried this.
Yeah.
We've seen benefits of it. Yes. And have been working with time, but we also see the other end of it, since we have our own.
I would love to use multivariate analysis to understand the relations between the results in your wastewater treatment plant and what is actually affecting those results. So
experience and knowledge, and maybe that's the part of knowledge for the one that's running the wastewater treatment plant, because maybe they don't have the knowledge around those kind of chemicals. So I think that could be an issue, and that was my question also: how much knowledge or training that we need to do with the one running the wastewater treatment plants and so on. I think that could be somewhere we need to put our efforts.
And I think also this kind of projects could also engage the personnel to be involved and learn that this is actually important, and why it is important, and so on.
Yeah, I think that is really important to involve.
Absolutely. No, and also not just bringing the data, but also the experience from the personnel. That's also extremely important to have a dialogue.
Sometimes the chemical suppliers own the process of this type.
Yes.
So were they also included in the?
They have been. They have been included. More. They
set the.
Exactly. Exactly.
What's behind that, or the research behind that is often maybe then the chemical suppliers are not at the users.
No. So they could be more or less enthusiastic about this kind of project.
Sharing.
And they almost also say, it's not just experience, it's a lot of knowledge, but
sometimes they also have really good ideas.
Yeah, absolutely. But you should really bring them on board. They are very important.
Yes.
So you should find those that are engaged and wants to co-work.
I got stuck on the sending away the paper and like waiting 1 week to get the result. when the process operators need the result now in order to take action.
Mm.
Otherwise, you can kind of lose production. You're not waiting for the results. So how far have like the equipment suppliers come with not having to send because as an even on my time it's like so how far is it from online processing, because that's where you can hear the process.
Yeah, I think you have better knowledge on that. Someone here working with the process. Still.
It's a little bit so yeah.
But we have for coping with
Okay.
Coating weight, don't they have galvanometer, Kemmetal have something that is
Giving me an indication, but still sure process in case you want to adjust it based on the.
but for crystal size, I think it's the 7th.
I think so too. So you have an idea, maybe with other methods that you really want.
But do you send them away then? Those.
It depends. I think
different.
some of the OEMs, they have their own.
Okay.
Often not in close to the process. No, that's true. Not in every time. Yes, one more. Yeah.
I got more of a general question, and that's how big of the environmental impact is surface treatment of the product? Like if you take a cabin. And the follow-up to that one is how much improvement can you get with using this process?
I don't got that answer. I've not made an LCA on it, but I think there should be. Maybe you have done.
We've had one project where we compare thin film pretreatment with the zinc phosphate, but then that's something different. But then we have some idea, but that's mainly the what you save there is that you need less energy because the process baths have a lower temperature, for example, and you use less chemicals. But then it's different. So the comparison to an optimized process and that I don't know, maybe.
But usually you say that surface treatment is the single biggest consumer of water, energy, and chemicals at the whole plant.
At the plant, but then you don't count the scope 3.
Yeah.
So, I was thinking of how big of a pie chart is surface treatment from a product, like a cabin or whatever, complete. It narrows down if you're going to focus on it when you look at the whole product. When you spend your effort.
Manufacturing plants, it's that guy in many aspects. But from a product, I guess it's lower.
Yeah, if you compare it to electronics and batteries and everything.
The energy wise, page of things in pie chart for BMW, which is at 60% of the page. And the rest is volume,
But the source material is also open pre-treatment or also. Yes, 10:20 is, no, 11:20 is the time. So let's continue with the program, and then we will leave the process baths for dry pre-treatment or dry treatments that I will talk about. So we have at least one new person joining the room, so welcome.